So, again, write down what's in the box. That's super important. We're going to look at problems in that form. And then depending on what you get when you do b squared minus 4ac, we're going to classify the conic. And then we're going to write it in standard form. It's pretty challenging getting it into standard form. We have to go back to a method we used way back when called completing the square. I have spoken to several trig teachers. They said this is one of the most important things to do with conics. So, especially if you were taking trig pre-calc next year, make sure you are paying extra attention to this process as we're going through it today. I said this earlier. I know some of you were in and out of the room. This is a continuation of Monday's lesson, so there is no new heading or anything. This is still 10.6. You could write 10.6 day 2 if you want, or just start where you left off. So again, these examples pick right up where Monday left off. So Monday's last example was 7. Today's first example is 8. The directions say classify the conic section and write the equation in standard form. So, I already showed you guys the answer. It's a circle. But how would we get that? How would we determine on our own that it's a circle if the magical answer does not pop up? We need to do b squared minus 4ac. I'm going to do it off on the sideboard. So, b squared is the coefficient in front of the xy term. Is there a coefficient in front of the xy term here? No, there's no xy term. So, b is 0. So, 0 squared minus 4 times, what's 1? Or sorry, what's a? Not 1. A is 1. Yeah, I gave it away. And what's c? C is what's in front of your y squared term. 1. Good. This is 0 minus 4, which is negative 4. Negative 4 is less than 0. So we have narrowed it down to circle and ellipse. You need to decide if A equals C or if A does not equal C. Do A and C equal each other here? Yes. Yeah, they're both 1. So that's why this one's a circle. That is pretty challenging. You got to go back to that formula every single time. Do b squared minus 4ac. That's why I even wrote it up on the board for you. Any questions? Now, once you determine that it's a circle, we have to get it into standard form. Remember, circle, you have your x and y on the same side, and then it equals the radius squared. So, here's where the challenging part comes in. The first thing you want to do is get your x's together. Leave a space, because we're going to have to add something there. So all I did was write the x squared and the x by each other. Then I'm going to write the y squared and the y term by each other. Leave another space. And then anything else just needs to go to the right side. So I'm going to subtract 11 from both sides. Now, you remember from Monday, when these are not centered at 0, 0, you'll have x minus something, in parentheses, squared. So that's our whole goal, is to get x minus some quantity squared. The way we do that is we complete the square. Do you guys remember how to complete the square? You divide the coefficient in front of your x by 2, and then you square it, and you add that number to both sides. It's been a while. What is 8 divided by 2?
4.
What is 4 squared? 16. So I need to add 16 to both sides of my equation. The whole reason we do that is so that we can factor it. What is negative 4 divided by 2? And what's negative 2 squared? Positive 4. So we're also going to add 4 to both sides. Now, let's think of how this would factor. What are two numbers that multiply to 16 and add to 8? 4 and 4, right? So I could write this as x plus 4 squared, which means my center has an x value of negative 4. It's like minus negative 4. Now, what multiplies to 4 adds to negative 4? Negative 2 and negative 2, right? So this is going to factor to y minus 2 times y minus 2, or y minus 2 squared. Remember, this process is called completing the square because it always makes them factor into a perfect square like these. Okay? Negative 11 plus 16 plus 4 is 9. What is the radius of this circle? 3. Where's the center? It's whatever they're subtracting from here, so negative 4 and positive 2. So the completing the square step is super important in getting this into standard form when the center is not 0, 0. That is your answer. What are your questions? It's kind of tricky, but we will have lots of practice. All right, here's our next one. All right, some of you might just be able to tell, but we'll go through the process anyway. What is b squared? What's b? B is with your xy term. So do we have a b? B is 0. So 0 squared minus 4 times, what's with your x squared term? 1. What's with your y squared term? 0. There is no y squared. So this would be 0 squared minus 0. So we are getting 0 for our b squared minus 4ac. So what type of conic is this? A parabola. When it equals 0, it's a parabola. Now, some of you might have just been able to tell because only one of the variables was squared. That's usually a good tip-off that we are talking about a parabola. So, standard form for a parabola has the x squared quantity on the left, and then we'll have the y quantity on the right. So, let's start working with the x's. We're going to have to complete the square to see what is the quantity that we're squaring for our x's. And then we want the y's on the other side. This is the tricky part. What is negative 6 divided by 2? Negative 3. Keep that in mind. We'll use it in a second. What is negative 3 squared? 9. So you need to add 9 to both sides in order for this to factor properly. So whatever you got when you divided this by 2, that's what goes in your quantity that you're going to square. So this is actually x minus 3 squared. The reason is this piece now factors x minus 3 times x minus 3. You want to write it as the quantity squared. That's why we did the whole completing the square process. Now, we got some like terms on the right. We have negative 13 plus 9, which is negative 4. Typically, we also write this side in factored form, so you can easily tell where your center is and what your p-value is. So I'm going to factor out a negative 4 there, and I get negative 4 times the quantity y plus 1. Now, this is standard form for a parabola, not centered at 0, 0. Let's just practice real quick. Where is the center? 3, -1. Good. We also know that it's opening down because P is -1. Questions on this? All right. Whoa. This is a long one. All right, I need to start by doing my my b squared minus 4ac. I don't think we're going to have a b here either. So is there an x squared term? Is there an xy term? That's what I meant to start with. No, so that's going to be b squared is going to be 0 squared, again, minus 4. Now I want the x squared term. -9. And the y squared term, 16. Now, what type of number is that going to give us? It's going to be a -4 times a -9, so it'd be a positive number. Once you decide it's a positive number, it's what kind of a conic? Hyperbola, because the b squared minus 4ac is greater than 0. So you don't even actually have to evaluate it. Once you decide whether it's positive, negative, or equal to 0, you can decide what conic it is. This is a hyperbola, as we just said, because we are going to get a positive number for b squared minus 4ac. Now, standard form is going to be a little tricky here. Let's start by getting our x's together and our y's together. Now, you'll notice that as I'm writing this, I did my y's in front. Does anyone know why that might make more sense for the hyperbola? Is what? Remember, hyperbola, the sign in the middle is always a minus sign, so if you notice that one of them is negative, you should write that one in the back. But that's something you could always fix after you complete the square, so I wouldn't stress too much about it. If you didn't do it yet, you'll have a chance. So I collected my y's in the front because those were positive. I subtracted the x's next because they had a negative coefficient. The only thing I haven't done anything with is that -161, so I will get that to the right side. And then we will start completing the square. You may recall you cannot complete the square until your coefficient with the x or y squared term is a 1. So I'm going to factor a 16 out from my y's, and I'm going to factor that -9 out from my x's. All right, we need to complete the square. So what is 4 divided by 2? And then square it. 4. So I need to add 4, which means, this is tricky, everybody watch. 4 times 16 is what I actually added to the left side. Everybody see that? Because you distribute this 16 to see what you actually added. So what do I need to add over here? I can't just add 4, they wouldn't be equal anymore. You have to add 64. That's a very tricky step. Over here, -6 divided by 2 is? -3, and -3 squared is? +9. So on the left, inside parentheses, I'm going to add 9. What am I actually adding, though? -81. So in order to keep them balanced, if you add a -81 to your left side, you have to subtract 81 from the right side. Now, if you think about how this would factor, two numbers that would multiply to 4 and add to 4, it's 2 and 2, so you'd have y plus 2 times y plus 2, or you can write it as y plus 2 squared. Back here you'd have x minus 3 times x minus 3, or x minus 3 quantity squared. You still have those coefficients in the front of each. And then when you combine like terms on the right side, you get 144. That works out nicely. Now, hyperbolas always equal what? Equal 1, right? So how am I going to turn this into a 1? Divide everything by 144. Now we can simplify those. 16 over 144 is 1 over 9. 9 over 144 simplifies to 1 over 16. And then on the right side you have equals 1. So my final answer here is y plus 2 quantity squared over 9 minus the quantity x minus 3 squared over 16 equals 1. And then you can just double check this is a hyperbola. That's what we set out to write. So we are good. What are your questions? Number 11. All right, back to b squared minus 4ac. B is the coefficient of your xy term. Do we have an xy term here? Xy. No, so this is going to be 0 squared minus 4 times your x squared term. 4, your y squared term, 1. So it's going to be 0 minus 16. That's definitely a negative number. So we are down between circle and ellipse. Does A equal C? The coefficient of your x squared term equal the coefficient of your y squared term? No, so this cannot be a circle. What's the only one that's left? Ellipse. Good. All right. I'm going to get my x's together. Leave a space so I can complete the square. Get your y's together. Leave a space so you can complete the square. Get everything else on the right side. So I need to get rid of that plus 4, so I subtract 4. All right, before I can complete the square, I got to factor that 4 out from my x's. My y's are actually good to go. What is negative 2 divided by 2? Negative 1 and negative 1 squared is 1. So I need to add 1. But what do I need to add to the right side? 4, because this 1 is being multiplied by this 4. So I'm actually going to add 4. Negative 4 divided by 2 is? Negative 2 squared is? 4. So I need to add 4 again. Now, two numbers that multiply to negative 1 add to negative 2, negative 1 and negative 1. So you can write it as x minus 1 quantity squared. Still have the 4 out front. How's this one gonna end up? It would be negative 2 and negative 2, which is y minus 2 quantity squared. These, we call it completing the square because they'll always be squares. Okay, so it's going to be the same number times itself gives you this, add them gives you this. And then that equals 4. We're almost there. Standard form equations for an ellipse always equal 1. How do I get this to equal 1? Divide everything by 4. So So those 4s are going to give us a 1. Those 4s also give you a 1. There is your equation for our ellipse. Where is this ellipse centered? 1, 2, right. Horizontal or vertical major axis? Vertical, because the larger number's under the y squared term. Good. Questions? All right, back to this same old homework assignment I gave you guys on Monday. Tomorrow there is a section 10.7. I wasn't originally planning on teaching it, but I do just want to kind of show you the types of problem because you will see them in the future. So we're probably going to look at examples from 10.7 for about 10 minutes tomorrow. And then the rest of class you can work on the 10.6 homework. I am going to give you some suggestions on practice problems for 10.7, but those will not be on the homework check. So you can use most of your in-class time tomorrow for 10.6 questions, so make sure you get a good jump on that tonight.